Good morning, everyone. Today's class is going to be a super interesting. We are not just going to talk about AI predicting things, but how it can actually explain what it's doing. So, ever wondered how does an AI think, or how can we see what's going inside its brain? Okay, so perfect. Today, uh, three big ideas are learn to explain, feature visualization, and then deep visualization. So by the end of, you will be able to see and understand how AI reasons almost like peeking inside its mind. Cool? Okay, right. So the next slide. What is learn to explain? All right, okay, let's start a simple. Imagine one of you writes an answer in the exam. I ask, how did you get the answer? And you say, I just guessed, right? So would I give the marks for that? No. Okay, exactly. I will say, show me your steps. Similarly, in AI, learn to explain means the model not only give the answer, but also explain how it got there. For example, the AI says the loan rejected, then adds because the income was below 30,000. That's what we call a learn to explain model. Okay. So think of it, it's like a AI showing the rough work. Yes, the it's like AI showing her working to earn full marks. Okay. Then the next slide. Why learn to explain is important. Okay. Now tell me, why would we ever want an AI to explain its decision? Your answer may be to build the trust, right? Exactly. If a doctor or banker uses an AI, they must trust the output. So the main reason are first one, the trust. Okay, well, trust me, the people believe in the system if they understand it. Second one, transparency. So we know what's happening inside. Third one, debugging. So we can catch the errors and biases. For example, if you're hiring a AI, keep rejecting the female candidates because of bias in the data. So an explainable model will show that the pattern. That's powerful, right? We go for the next slide. Okay. The next slide, supervised explanation learning. Okay, so it is breakdown into main three types. So first one is supervised explanation learning, second one is joint training, third one is post hoc explanation learning. The first one, supervised explanation learning, means we train the model using the data that already has explanation. For example, loan rejected because income low. So the AI learned that the logic from the example. Second one, joint training. So the model learns to predict and explain together. So for example, a disease detection AI. So it predict the pneumonia and at the same time explain because lungs show cloudy patterns. Then the third one, post hoc explanation learning. So the model first predict, then afterward try to explain what it did. So like writing your exam answer first, then showing your rough work later. Okay. So post hoc is like explaining after the fact, right? We go for next slide. Applications of learn to explain. So now where do we use this idea in the real time? So you have to tell the medicine, finance, teacher, etc. Okay. So exactly, the also finance, education, and even self-driving cars to uses this idea in real time. For instance, in healthcare, the AI can say pneumonia detected because of the cloudy lungs in X-ray. In banking, the loan rejected due to low income and a high credit risk. In education, the math answer wrong because of wrong step in subtraction. You see, AI plus explanation equal to better feedback and more trust. So, students, so it's think like a AI becoming a teacher too. Okay, AI that can teach back. That's the dream. Fine. The next slide, feature visualization. So now let's step into the something more visual, feature visualization. So how many of you have seen AI image with the red and blue heat maps? That's the feature visualization. It shows which part of input made the model react. So think of an CNN. First layer see the edges and the corners. Middle layer see the shapes and the patterns. And the last layer see objects like a cat or face. Okay, the first layer see edges and the corners. The second layer see middle layers and the shapes in patterns. The third layer see whole objects like a cat or face. So the visualization let us peek inside and say, okay, that's what my AI is looking at. Okay, have you clear? Go for next slide. Okay, let's quickly go through the main types of feature visualizations. Okay. So first one is activation map. Second one is deconvolutions or gradient ascent. And then third one is class activation. So first one, activation map, show which part of the image light up the particular neuron. And then gradient ascent, reconstruct the pattern that excite the neuron most. Third one, grad cam. So super popular method, it overlays a heat map showing which part of the image AI focused on. For example, if you show a cat image, the grad cam might highlight the cat faces. That means I looked here to decide it is a cat. You can see the picture in the PPT. So it's like a AI pointing with the flashlight saying the spot matters. Right? Why feature visualizations matters? The next slide. Now, why do we even need visualization? Yes, visualization help us understand what's happening inside, detect the wrong focus areas, which mean detect bias or overfitting, debug errors and build trust. For example, if an AI says dog, but the heat map highlight the grass, not the dog, that is the big problem. So it means it's learning wrong patterns. Okay. So it's like a giving an AI an eye exam. So example of GradCam in action. Let's take a medical example. Chest X-ray image. The AI predict pneumonia. We apply the GradCam and see the bright and patches over the lungs. Okay, great. It means the AI looked at the right spot. But what if the red area is around the hospital label in the corner? Then oops, the model is cheating, right? It learned the wrong shortcut. Okay. Now we go for deep visualization. So here we are not just looking at the one layer, but how learning the grows layer by layer. First one is early layer, detect the edges. Second one is middle layer, detect the shapes or textures. Third one is later layer, detect the faces or objects. Okay, so it's just like a baby. So first learns to see the lines and then shapes, then faces, then mom and dad. Okay, it's just like a baby. First learn to see lines, shapes and then faces. Okay, then mom and dad. Now some of the main methods here are: first one, activation maximization. Second one, PCA projections. Third one, feature inversion. So activation maximization means we generate an image that most excites a specific neuron. For example, a neuron that detects eye will make the output look like a cluster of eyes. Okay. For example, a neuron that detects the eye will make the output it look like a cluster of eyes. The second one, TSNE or PCA projections. So we reduce the complex data into 2D to C clusters, like a grouping cats together, dogs together, etc. Okay. So then third one is feature inversion. We try to reconstruct the original image uh, from the features. Okay, we try to reconstruct the original image from the features. It shows what the model remembers. Okay, next slide. Deep visualization. So finally, how do we actually do all this? We use some tools. First one, TensorBoard, which means TensorFlow. Okay, for neural network layer visualization used with TensorFlow. Second one is look it. So Google's open source library for feature visualizations. And then third one is Captain PyTorch for model interpretability. Then fourth one is Line or Sharp for feature importance. So these tools let us see, compare and explainable behavior in way humans can understand. It is the magic of explainable AI, not just building the intelligent systems, but understanding theme and them. So this is the learn to explain and visualization differentiation. So in real world use cases, the healthcare can be used in the graph can highlight the affected organ regions, and then autonomous vehicle to visualize the focus on pedestrians or roads, and then NLP meaning natural language processing model, attention visualization for the word importance. Then fourth one is security. So visualize the how the model detect the anomalies. So let's wrap up class. So what did we learn today? First one, learn to explain. Second one, feature visualization. Third one, deep visualization. First one, learn to explain. So the models that justify their decisions. Second one, feature visualization. It helps us to see what AI sees. Third one, deep visualization. It helps us to understand how AI learns concept step by step. So next time someone says AI is a black box, you will say not anymore, right? Okay, next class we will actually try out a visualization tool and see the real heat maps in actions. Thank you students.